Hello dear student, how are you? I hope you all will be fine. I'm also fine, thank you. Welcome to your channel. Let's start today's topic. Today is lecture number 11 of nucleophilic substitution reaction. And today lecture we will be studied about, in previous lecture we are studied about the different effects, different factors that affect the Sn1 reaction. But in today lecture we will be study stereochemistry of Sn1 reaction. We will be study stereochemistry of Sn1 reaction. Stereochemistry of Sn1 reaction. Yeah, today we will be study the stereochemistry of Sn1 reaction. Let's start. In Sn2 reaction, I already told you, in Sn2 reaction there is only one product can be possible, that is called inversion. That is called inversion. What is meant by inversion? Inversion of configuration, only inversion of configuration will be possible. Inversion means when there is, let's suppose this is umbrella. When umbrella is caught by wind, when umbrella is caught by wind, it become like this. So this is called inversion. When umbrella is caught by, when umbrella is caught by wind and the umbrella become caught, so this umbrella is called, this change is called inversion. This is called inversion. Let's suppose similar, this is one carbocation, this is one carbocation H. Here is X group attached. In case of Sn2 reaction, when nucleophile attack on this carbon, it produce the final product become like this. Nucleophile, electrophilic carbon H. So it become invert. It become invert like the umbrella that become invert. Before it like that, but here it become like that. So this is called inversion. This is called inversion. When umbrella is caught by wind, this is called inversion. Yeah, this is in Sn2 reaction, but in Sn1 reaction, inversion and retention both are possible. Inversion and retention both are possible. What is meant by retention? Let's start. In Sn1 reaction, first of all, in first step or the initial step is the ionization process occur. What is first step? Ionization. Ionization is the first step. In ionization, ion produced. Ion is produced. Ion is like this. This is the first step in which ion are produced, plus X minus. These ions are produced. When these ions are produced, after this, that will become like this. This structure. This is the one lobe of one orbital. This is the another lobe of the same orbital, p orbital. So this have positive charge. So the nucleophile can attack from either side, or from left side or from right side. From either side it can be attacked. So that's why there will be two possible product can be formed. One possible product will be like that, nucleophile, plus one product will be like that. One product will be like that, in which nucleophile are from this side. So there are two possible structure, in which one from left side and in one from right side the nucleophile can attack. So these two possible structure, the structure in which the nucleophile attack from the back of the leaving group. This is the back of the leaving group, this is the side of the leaving group, this is the side of the leaving group. When nucleophile attack from the back of the leaving group, that leaving group left the groups, left the carbocation. So if when the nucleophile attack from this position, from the back to this position, it will be called inversion. When the nucleophile attack from that side, from which leaving group left the groups, that will be called inversion. So this product will be called, the second product will be called inversion product, while this product will be called retention product. sorry, retention are those products in which nucleophile attack from this side to electrophile to this cation from which the leaving group left the group, sir. Yeah, there are two possibilities in which the orbitals become this orbital. There are two lobes of each orbital, each of p orbitals. So these orbitals have two lobes, one from the left side and one in the right side. So from the right side, the halide ion or the leaving group left the system. So that's why nucleophile can attack from both sides. In the sides from which leaving group left the groups, and nucleophile attack from this side, and this product will be called retention, while in which the opposite to the leaving group, the nucleophile attack, this product will be called inversion product. So there are two possible configuration present in Sn1 reaction. One is called inversion and the another is called retention. Yeah, you can also write in which the nucleophile attack nucleophile attack when nucleophile attack from front side of the leaving group, the product will be called retention of configuration. While in case of when nucleophile attack from the back side of the leaving group, the product will be called, generate the product called inversion of configuration take place. Retention of configuration will be like this will be retention of configuration when the product when the x left when the ions are produced let's I show you clearly. Yeah, the product will be like this. This is when the reaction take place and ions are produced plus x minus when nucleophile attack from this side, from the front side from which the leaving group left the carbocation. So this will produce a retention product. This will call retention product. This will be retention. While when the nucleophile attack from the back side to the carbocation from which the leaving group left the group to the back side of this side, so it will be called when the nucleophile attack from this side, so it will be called, it produce it will be generate the inversion product. This is the concepts of inversion and retention of configuration and inversion of configuration. I hope this point will be clear. As I explained that there are two possibilities in Sn1 reaction. One is inversion of configuration and one is retention of configuration. So there is the same number of possibility from the inversion and from the retention. So that's why that can be another term used here, racemization. So here is the possibility of racemization. Racemization is the mixture in which the same quantity, same number of retention product and inversion product, same number of retention product and same number of inversion product will be called racemization. Inversion product in which the configuration, retention and inversion both have the different configuration, so that's why in which one have clockwise configuration and another one has a negative anti-clockwise configuration. So that's why when equal the number of these products, so that's why they will make racemization. these two are also the enantiomer to each other, because in retention product will be like that. Let's suppose this is the first of all reaction plus, that is the first step of the, when this system, when this carbocation, when the nucleophile attack from the front side, that is the front side, when the nucleophile attack from the front side, it generate inversion, and retention, it generate retention product. Yeah, in case of from this side, in which the nucleophile attack from the back side, it generate inversion. So let's see that here is the configuration. Here in retention, the configuration will be either it will be left hand side. Let's suppose when there is CH2 group attached, here is H, here is H attached, here is H, here is H, here is CH3 group attached. When the nucleophile attack from this side, so the configuration will become anti-clockwise. While in case of here in inversion, so the configuration 1 2 3 according to CIP rule, Khan in gold ruler. So in according to this rule, the hair will be configuration clockwise. So these two, when so that's why these are the enantiomers to each other. These are both of inversion and retention are both of enantiomer. So we know that we can define racemization that it is the ratio of the two enantiomers, or you can also say the two enantiomers are produced in equal amounts. It is also called racemization. These are racemization. The product is either racemic. Mostly this Sn1 reaction, in Sn1 reaction mostly the product will be racemization. Product will be racemic mixture, which is optically pure, means it is optically inactive. This will be optically inactive. Optically inactive means it cannot be rotate the light, it cannot be rotate the plane polarized light, because in both here both configuration are present, that is clockwise and anti-clockwise, and both have same quantity. So that's why the net result of the rotation of light will be zero, cancel out, and the means when there is 50% retention product and 50% inversion product, and we know that the retention rotate the plane polarized light in anti-clockwise direction way, while the inversion rotate the plane polarized light in clockwise direction. So when the concentration of both these are same, that's why the net result of the light plane polarized cannot be rotated, so it will be called optically inactive. I hope this point will be cleared. Let's do an example on inversion and retention. Let's do one example on retention and inversion. Yeah, let's do one example. So CH3, CH3, CH2, CH3, C, CH3, CH2, CH3. Here is H, and that is bromide ion. When the bromide are left the groups in the first step, it generate C plus, it means it will become like this. This is the one lobe of, this is the two lobes of one p orbital. It is H, CH3, CH3, CH2. So here two possibility present. Here two possibility present. When the nucleophile plus bromide ion, when the nucleophile attack from this side, when the nucleophile attack, let's suppose the nucleophile is methanol CH3OH. When the nucleophile attack from this side, it produce retention product. It will be called retention because it is the front of the from where it is the front from where the leaving group from where the bromine left the carbocation. So that's why it will be called retention. So the retention product will be like this. This will be the retention product, CH3 C CH3 H. This will be the retention product, OH CH3, that has plus charge. While from the inversion product, that will be called retention. That will be called retention. From inversion, in which the nucleophile CH3OH can be attacked from this side, from the back side. When which from the back side, inversion product will be formed. Inversion product will be formed, and inversion product will be like this. That is CH3CH2. CH2CH3. So the inversion product will be like this. CH3CH2 CH3 H, and this is OH. So these two products are CH3 plus charge. So these two products are enantiomer to each other. These are also mirror image to each other. These are enantiomers. So that's why the product will be the mixture will be racemic mixture, and the mixture will be optically inactive. The mixture will be optically inactive because both have same compounds. The mixture will be optically inactive because both have same quantity of the same ratio of the inversion and retention. That's why the net result of the plane polarized light cannot be affected by any of the retention or inversion, so the net result will be 0. And these are about the stereochemistry of inversion. I hope this point will be cleared. If you have any confusion, if you have any question, you can also ask me in comment section. But in most cases here, in most cases, the retention product will be the concentration of retention will be less in most product. It will be become 40%, while inversion will be 60%. It is because the reason behind this, the inversion product will be greater in the concentration in mixture because from the front side, when the nucleophile attack from the front side, here is little bit the leaving group that left the carbocation, that left the system. So the leaving group all little slightly sterically hindered, or you can say that it will hinder the coming nucleophile to attack on the electrophilic carbon. But from the big sides, it will be very easy. Here is no hindrance to the nucleophile that attack on the carbocation. So that's why the retention product will be 40% and the inversion product will be 60% in most cases. But there is also lots of cases where flat carbocation present. In case of flat carbocations, the ratio of the retention and inversion will be 50-50%. So there will be racemization occur in where flat carbocation is present. These all are the about stereochemistry. If you have any confusion, any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I dropped in description box. You can get from there. Also, please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my dear student. Very best of luck.